Right. Welcome back. Hope you had a good weekend. Today we're going to look at Unit 10, Lesson 2. We're going to talk about reactions with acids and bases. So we're really going to look at two different types. So we're going to talk about how acids react with metals, and you should be able to predict whether or not an acid will react with a certain metal. And then we'll look at how acids and bases react with each other. Okay. So let's do a little do now first. Question one is just kind of asking what it means to neutralize something. So any time you've heard that word used before, what does it mean? And then number two is a review question, just so we're all on the same page from the first lesson in the unit. So go ahead and pause, try these out, and come back. Okay, so you can have a few different answers for number one, right? Neutralize, maybe you said to cancel out or to get rid of or to make even or to balance maybe. All those are fine, right? And what we're going to see is that in terms of acid-base reactions, they're actually called, when you mix an acid and a base, it's called a neutralization reaction, right? Because something that's acidic and something that's basic, when you mix it together, they neutralize and they become, well, they move closer to pure water, actually. They become less acidic and less basic, right? They neutralize each other. So that's why I was asking about that. And number two, remember, Arrhenius acids, what you're looking for there is the hydrogen in front, okay? So we're looking at A. A is going to be the correct answer. This is a hydrobromic acid, I believe. So we have the H in front. That's what you're looking for an Arrhenius acid. This is an Arrhenius base because it has the hydroxide group at the end. And this, NH3, right, it's neither an Arrhenius acid or an Arrhenius base because it doesn't have the H in front or the OH at the end, right? Don't be fooled. That H at the end, right, does not mean it's an acid. For Arrhenius acid, you're really looking for the hydrogen that's in front, okay? All right. So let's talk about acids and how they react with metals. So a little bit of background here. Also, this table, I'm not sure exactly, I can't remember which table it is. I didn't include the letter, but this is in your reference table, okay? So this table shows the relative chemical activity of metals and nonmetals, all right? So we got metals on the left, nonmetals on the right. And they're arranged in order of decreasing chemical activity. So the most active metals are up here at the top, and the least active are at the bottom. Okay, so lithium is very reactive, all right? If you just have a block of pure lithium, right, if you even get it wet, it's going to like explode, right? Very reactive. And as we go down, it becomes less and less active, less and less likely to go through a chemical reaction, okay? Now, maybe you noticed H2, right? Hydrogen is technically a non-metal, right? It's that kind of exception where when we were looking at the staircase and everything on the right is a non-metal, everything on the left is a metal on the periodic table. Hydrogen's kind of off by itself, but it looks like it's on the metal side, but it's technically a non-metal. Now, why is it on the metal side? It's because we kind of like to compare the reactivity of all these metals to hydrogen. So it's there so we can compare all these metals to it, so we can see where it fits in with the rest of the metals, and you'll see that it's going to be really helpful for us when we're talking about the reaction between acids and metals. So here's how we do it. It's very straightforward, actually. So a metal will react with an acid if it's more reactive than hydrogen, right? So it's going to replace the hydrogen in an acid is really what that means, okay? So all of these metals above H2, okay, are reactive, will react with an acid. So if you put any kind of acid on, let's pick a random one here, titanium, it'll react. Acid with cobalt, it'll react. However, right, you can probably assume the next part, if it's below H2, if it's less active than hydrogen, it's not going to react. Now, I don't know if you know what these three elements are, but they're really easy to remember which ones don't react, all right? Copper, silver, gold, all right? Just think of like the metals you would get for first, second, and third place. Those don't react with metal. Now, there's a reason why we value those like gold and silver. It's because they don't react and they don't tarnish, they don't rust. They don't, right? They don't degrade over time, right? It'll stay um, just like it is for, you know, however, forever. Okay, so right, I was just saying this. The reason why these metals react with acid is because they're more reactive than the hydrogen that's present in acid, right? We're always looking for that hydrogen in front. And what will happen is when you react an acid with one of these metals, it'll make hydrogen gas, H2, and a solution of a salt containing that metal. All right, and we'll talk a little bit more about that in a second. And yeah, the last thing, like I already said, these metals down here do not, they don't react with acids because they're below, they're less active than H2. All right, so everything above H2 is going to react with an acid. Everything below H2 will not react with an acid. Okay, so try this one out. Actually, try both of these out. I'll put them both up. So you're going to use this activity series to predict which of the reactions will actually occur. Only one of these reactions will actually create some products. The other reaction won't happen. Okay, and then for the one that will occur, write the complete balanced equation and identify the salt that formed. Okay, and the salt will be the other thing that's not H2. All right, and I just gave you a little hint there. Remember, these make H2 hydrogen gas, always going to be produced. Okay, so pause and try those two out, and then I will go through them. Okay, so hopefully you noticed. Let me go back here, actually. Right, copper, not going to react with acid, right? It's below H2. So zinc, being above H2 on our table here, is going to react. So this is the reaction that's going to proceed. So let's write out the balanced equation for this reaction. All right, we have zinc, and that's solid zinc, plus HCl, that's our hydrochloric acid, right? Aqueous, it's in water. Okay, so remember, what we're going to get here is we're going to get hydrogen gas, which is H2, and that's a gas. Now, what's going to be left over? Well, look, if we're using up the hydrogen, we have this zinc and chlorine. Okay, zinc makes a positive ion, chlorine makes a negative ion. So zinc has a 1 plus charge, chlorine has a 1 minus charge, and zinc, I believe, is a 2 plus, right? So if you're doing the crossover method, if you're writing the product out, zinc is 2 plus, and you can look that up on your periodic table. Chlorine is 1 minus. You do the crossover method, you get ZnCl2. Okay, that's a little bit of review there, right? The 1 goes down, 2 goes over. Remember, it's just about balancing the charge. So how do you balance out the 2 plus with a chlorine? Well, you need 2 of them because each of them are only 1 minus. All right, so we get ZnCl2. Write that. Getting a little cramped there. Okay, so now we want to make sure it's balanced, right? Don't forget, we have what we need. Okay, so this is our hydrogen gas, and this is what we call a salt. Now, I'm going to say more about that in a minute. All right, so let's balance this real quick just for a review. So it looks like zinc is good. Chlorine is not. So I see 2 chlorines here, only 1 here. I'm going to put 2 here. So that balances that. And look, it also balances our hydrogen. That's it. Pretty straightforward. So it's 1, 2, 1, 1. Okay? But the key point here, right, we have zinc reacting with an acid. And remember, it produces hydrogen gas. That's H2. Don't forget the 2. Okay? And then you basically have to look at what you're left with, zinc and chlorine, right, which is going to make zinc chloride. And to figure out the formula for zinc chloride, you need to do the crossover method, okay? And you get ZnCl2. That's our product. And that's going to be our salt. So this is going to be the salt. And I'm going to say more about that in just a moment here. Okay. So, so that was a reaction between an acid and a metal. Now we're going to talk about neutralization reactions. Okay, so neutralization is the reaction between an Arrhenius acid and an Arrhenius base, and it always produces water and a salt. Now, here's that word salt again, right? And most people think salt, they think table salt. Well, yeah, that can be one type of salt. And there's the formula, right? Acid plus base makes salt and water and salt. So a salt is an ionic substance composed of positively charged metal or polyatomic ions and a negative ions other than the hydroxide ion, right? So it's going to be the ionic compound that's left over at the end of this neutralization reaction. So you're always going to have an acid and a base, and it's always going to make water. And then the leftover stuff, it's going to be an ionic compound. You're going to have a positive and negative ionic compound, and we call that a salt. Okay? So before we do an example of a neutralization reaction, I want to just make sure you know that these are also in your reference table, okay? Common acids and bases. And sorry I didn't put the letters of the table, so you're going to have to flip through and find it. But yeah, common acids and bases, okay? These are pretty much the only ones you're going to see in this class in terms of these two. Notice, right, the bases, these are Arrhenius bases. They have the OHs, right, the hydroxide groups. NH3 over here, not an Arrhenius base, but often acts like a base by accepting hydrogen, right? That's a Bronsted-Lowry base. Okay, so just be aware that if you see a name and you don't know the formula, this is where you look. Or if you need the name for a formula, which is less likely to happen, but if you do, this is where you want to look. Okay, so let's write the neutralization reaction between, let's see, nitric acid, dilute nitric acid, right? You don't have to pay attention to this. Nitric acid and potassium hydroxide, right? So here's an example where, okay, I don't know what those are in terms of formulas. Well, boom. Nitric acid is HNO3. I'm going to write that down on my paper here. HNO3. And I think, yeah, potassium hydroxide. That's right here, KOH. Okay, we have our reactants, our acid and our base. Okay, so here's what we're looking at here. Here's our nitric acid, here's our potassium hydroxide. So, in every neutralization reaction, we're going to get water, okay, as one product, and our salt is going to be the leftover kind of ions that are going to form the ionic compound. So let's just be real clear here. Where is this water coming from? Well, remember, Arrhenius acid always makes hydrogen ions, and an Arrhenius base makes OH ions, right? So if you combine them, if you combine the H, the O, and the H, write it like that, 2 H's, 1 O, that's H2O, okay? So when you mix an acid and a base, you always get water, which is neutral, right? We'll talk about pH later in this unit, but that'll be a pH of 7 is totally neutral, and that's just pure water. But that's why they cancel each other out and become neutral, because they make this pure water from HOH, that's H2O. All right? So what is our salt? What is the ionic compound that's left? Well, if we I'm going to cover these up, right? If we kind of cover up the OH, we have potassium, and we cover up the hydrogen, we have NO3. That's nitrate. Okay, well, potassium is +1, nitrate is -1, and if you didn't know that, it's in your table of polyatomic ions. So what's that going to make? Well, potassium nitrate. Okay? And remember, I didn't have to do anything to it because potassium, from the periodic table, it's in the first group. It's a +1 charge. NO3, if you look at the table of polyatomic ions, has a -1 charge. So all you need is one of each to I don't want to use the word neutralize, to kind of cancel out the charge and become neutral. Okay, so this is simply just KNO3. Okay, so here's our neutralization reaction. We have our acid, we have our base, we have water, and our salt. Okay? Oops, I forgot my water. Okay. So, I mean, yeah, that's as hard as it's going to get, okay? But it's going to happen every time. Every time you're going to have Arrhenius acid or Arrhenius base. The H and the OH will make the water, right? And then you're left over, and you got to be careful here, though, right? It's not NO3K. Always remember the positive ion comes first when you're writing these formulas. So Yeah, you get acid plus base, water, and a salt. Okay, and that's really as tough as it gets. Okay, so going back to the PowerPoint here, yeah, we're already there. We're at the check for understanding. Um, so go ahead, pause, try these at least these first two questions out, and a challenge question if you are feeling bold. Okay, and when you unpause, I will go through them. All right. So number one, will hydrochloric acid (HCl) react with magnesium? And how do you know? Right. Well, we're talking about a metal here. Magnesium's a metal, so how am I supposed to know if it reacts? Well, that's what we use this table for here, right? Magnesium is a pretty reactive metal. It's up here, Mg. It's above the H2, therefore, yes, it's going to react. So how do we know? Well, magnesium is more reactive than H2, therefore, it will react, okay, with the acid. Okay, so yes, HCl will react with magnesium to make hydrogen gas, right, and magnesium chloride as the salt, right, what's left over. Okay, number two, write the balanced equation for the neutralization reaction between sulfurous acid and calcium hydroxide. All right, so I'm going to look up what these are in the table. So sulfurous acid, calcium hydroxide. Sulfurous, there it is. So it's H2SO3. H2SO3. And I forgot what the other one was. Calcium hydroxide, I think. Yeah, calcium hydroxide. That's right over here, CaOH2. Okay, got that written down. All right, let me go to my, here we go. So there's our sulfurous acid and our calcium hydroxide. And remember, neutralization reaction, what do you always get? H2O, okay? Oh, I just realized. No, this one was balanced. Okay, this one might not be so easy. Okay, so we have our water. Now we got to figure out what the salt's going to be. Well, the OH and the H make the water, so what's left over? I have calcium and I have, I believe that is sulfite. Okay, so calcium is a 2 plus ion, okay, and SO3, I'm not sure what the charge of that is. I hope it's 2 minus, but it might not be. So I'm going to actually go to my reference table. See, I don't have these memorized either. Reference table. Okay, I'm going to my, good, table of polyatomic ions. SO3, 2 minus, good, and it was sulfite, nice. All right, so it is a 2 minus charge, nice, proud of myself, 2 minus, okay. So this is good because 2 plus, 2 minus, it works, it's nice and balanced, so it's just gonna be one of each of these guys, which means our salt is CaSO3, okay? So we have sulfurous acid plus calcium hydroxide makes water and calcium sulfite. All right. And because that was so evenly done, nope, this is not balanced this time. Okay, not super easy like the last one was. So let's put these dashes so we know what to write our coefficients. So right away I'm looking at, let's see, I have 2 oxygens. I'm going to kind of ignore the calcium and the sulfite because they work out nicely. There's one of each and there's one of each here. So I'm just going to focus on the water and these guys. And I'm betting that I'm just going to have to put a 2 here because if you look at all these, I have 2 waters and 4 oxygens, right? 2 waters here, or 2 waters, 4 hydrogens and 2 oxygens. Sorry, guys. So 2 oxygens here, 2 hydrogens there, and then 2 more hydrogens here, which means if I just do this, it's going to be balanced, okay? And I'll prove it to you if you want, right? I'm going to treat SO3 as a singular thing, right? If the polyatomic ion stays together, then you can kind of treat it as one thing, like one unit. So I have 1 SO3 here, 1 SO3 there, 1 calcium, 1 calcium. I have 2 hydrogens plus 2 more is 4. That works out. And I have 2 oxygens there. That works out. All right. So there you go. But for this lesson, really, if you can come up with the formula without balancing, that's really where I want you to be anyway. But, you should still be able to balance these things. Okay, so that's it for, I think that was it for that question. Yeah, we wrote the balanced equation for the neutralization reaction. Cool. All right, so we are done. I'm going to go over the challenge question if you want to stick around. Um, yeah, okay, so let's look at this challenge question. Write a neutralization reaction where the salt produced is potassium chlorite, KClO2. All right, okay, so it's a neutralization reaction, right? So, but I don't know what I'm starting with this time, okay? So, and again, pause and try it yourself if you'd like. But I know it's a neutralization reaction, so I know I'm going to get water. And it told me what the salt is. It's, well, what was it? Oops. KClO2. Okay, so I need an acid and a base where the salt produced is KClO2. Well, I know it's going to be something with an OH for my base, right? Has to be for this Arrhenius base. So let's get that potassium in there, right? We need the positive ion. That's a positive ion. So potassium hydroxide will work. But now I need to get that ClO2, right? So ClO2, okay. So it has to be an acid, so it's going to be a hydrogen in front. I just want to make sure I write the right formula. So I can tell from this formula that ClO2 must have a 1 minus charge because potassium is 1 plus, and this is neutral. So if this is a 1 minus, I only need one hydrogen in front to make this an acid. Okay? I'm not sure what this acid is called. I wonder if it's on our table. What is it? HClO2. No, not a common one. Oops. Yeah, so I'm not sure what that acid is called because there's a naming system for these acids too, which I kind of forget about this one. But this is what I was asking for, right? Can I write a neutralization reaction where KClO2 is my product? There it is. All right. Now notice the salt is made up of that guy and that guy. And then the rest here, right? The HOH becomes the water. Okay. So, quick review, right? We talked about two types of reactions. We looked at reaction of acid with metals, always produces hydrogen gas and a salt, and neutralization reactions, which produce water and a salt. Okay? All right. So go ahead, try that homework out, and I'll see you guys next time.